Hi, welcome to Moksha Nagasri Maths Academy. Today I am going to explaining standard 10th real numbers. See, in the previous videos I told how to find out LCM and HCF of two numbers and more than two numbers also by using the factorization method and also the division method. See, now in the 10th standard, the first chapter real numbers, okay, what are the main problems in this chapter, okay, what are they, just we can see that. Okay, the first problem, just listen children. Find LCM, find the LCM and HCF. Find the LCM and HCF of two numbers find the HCF and LCM of two numbers. Okay, for example 21 and 91, 21 and 91, and also should do the verification and verify the result and verify the result. So how to verify the result and how to find out the LCM and HCF of these two numbers. Okay, generally you can find out that the factors, the prime factors of 21 as well as 91. Okay, now which is easiest method to find LCM and HCF. First you goes to that, find the factors of 21, that is also prime numbers. Prime factorization, you know that 3 is the prime number, no? 3 will go in 21. How many times will go? 7 times. 3 sevens are 21. Actually, these two numbers enough. If you want to convert into 1, then you can take off 7. So, 7 in 7, how many times? 1 time. So, keep it out. So, 3 into 7. The prime factors of 21 are 3 into 7, right? Take that 91 children. If you take 91, 7th table will go. How many times? 1 7s are 7, 21 will be 13 7s are 21. Actually, still here enough. Still, if you want to do that, 13 is prime number, you know that. 13 in 13, how many times? 1 time. Right? So that you have to write the factors of 21 and factors of 91. Just see children. Factors of factors of 21. What are the factors? 3 and 7, no? That means in a product form, you can write 3 into 7, right? Now, factors of 91. Factors of 91, what are the factors children? 7 and 13, no? So, write in a product form, 7 into 13. Now, you see that what are the common factors of both the numbers? What are the common factors children? 7, no? So 7 is the common factor. Only one number is the common factor in that. Okay, whatever you are taking the common factor, you know that is belongs to the HCF. Be carefully remember. So that HCF is equal to, what is the common factor? 7. So 7 only is the HCF of the given two numbers, right? Next LCM you has to find out. LCM is equal to, so actually 7 is the common factor. Okay, we can write as usual. Generally, when I have taken the other factors, there is no repetitions in the other numbers. 3 is not repeating and 13 are also not repeating, right? So that you can write 3 and 13. 3 into 13. Okay, that means what we have to find out that multiply this all 7, 3 and 31. Then you can get the LCM. Okay children, that means 7 into 3 into 7 into 3 into 13. So 7 3s are 21. 21 13 are 13 1s are 13. 13 2s are 26. 26 plus 1 27. Okay. So 13 1s are 13. 13 1s are 13, 13 2s are 26. 26 plus 1, 27. Okay, that means what? How much you are getting? 273. 273 is the LCM, right? Now we have to do the verification of these numbers. So when you are doing the verification, children, only one concept will be there with respect to LCM and HCF. That concept is belongs to LCM into HCF is equal to product of the given two numbers. Product of two numbers simply. Product of two numbers. See now, LCM into HCF. What is LCM, children? What is LCM? 273. 273 into HCF. What is HCF? 7. It is equal to product of the two numbers. What are the two numbers here? 21 and 91. No. Those only belong to the product of those only two numbers. That means if you think that A is the 21, B is the 91, then you can write LCM into HCF is equal to A into B. That also no problem. So product of two numbers means 21 into 91. Just you can check it whether it is correct or not. 273 into 7. 273 into 7 just multiply. What will become? 273. Just if you multiply that, 7 3 is 21. Right? 7 7 is 49. 49 plus 2, 51. 7 2 is 14. 14 plus 5, 19. 1911. Same thing has to get it this side also, no? 21 into 19. 91. Just you can see here. 21 into 91. That means 21, 9 1s are 9, 9 2s are 18. Just you see 1, 9 plus 2, 11, 1, 1 plus 8, 9, 1, 1, 9, 1, 1. Here also you are getting 1, 9, double 1, no? So that the product of, that means the LCM of 21 and 91, when you are finding that, you are getting 273 and their HCF is 7. For verification, you must remember that only this concept. Product of LCM and HCF is equal to product of the given two numbers. So LCM is 273 and HCF is 7. By multiplication of this 19, 11 you are getting. So product of two numbers, whatever it is given the two numbers, multiplication of these two numbers, that is belongs to 19, 11. So both will be same, no? Hence verified. It simply you can write it verified. Okay, this is one of the important problem with respect to LCM and HCF. Okay, and also the verification. Must and should this model, board exams and other exams also. Okay, children. Then we'll go to the next model. And also by using this concept, okay, now one more problem we'll do that. Just listen, children. So whatever it is given, you know, according to that 96 and 104. Suppose 96 and 404. For these factors we'll find out. Okay, now then we'll do the verification. Right? See how to do this problem. You should find out LCM 96 and also the 404. Before that, what I told you, must find out the prime factors, that also prime factors of 96. Just you can take that, children. 2 table will go 4 2s are 8, 8 2s are 16. Again 2 table 24 2s are. Again 2 table 12 times. Again 2 table 6 times. Right? 2 table 3 times. 3 is the prime number until here over. Still if you want to take 3 1s are 3. Right? So you will see that all these factors. Next we will go to that 404. What are the prime factors of 404? even number no, then you can take the 2 prime number no, 2 table go, 2 2 are 4, 0, 2 2 are 4. Again 2 table, 1 2 are 2, 0, 1 2 are 2, 1 not 1. So in the 101 is the prime number, children. So prime number means just you can take a 101. In 101, how many times? 1 time, right? Now you have to write what are the factors of 96 as well as 404. Okay, children. See factors of 96. Factors of 96. Okay, actually if you write in the exponent form, then it is easy to convert into getting LCM and HCF. See what are there here. 2 how many times repeated? Just you can see 1 2 3 4 5. 5 times repeated. That means what will say 2 to the power of 5 into what is left here 3. This is easiest for you for the LCM and HCF finding. And factors of 404. Factors of 404. 404 that what are the factors? 2 into 2 into 101. 2 into 2 means how much? 2 square. 2 square into 101. Now first we can find out the HCF. HCF of these two numbers. Okay children. So you written in the exponential form, no? Okay, so that concept what is there you have to think that. I told you already in the previous classes. Okay na? To find the HCF when you are expanding in the exponent form, okay, the least power of the prime number, the least power of the prime number of the given two numbers is called as a HCF. What is that? The least power of the prime number of the given number, then it is called as a what you call HCF. Okay, so whatever it is there, according to the many numbers, then we have to take all the powers with respect to their least power, right? See here, only the two pairs, 2 to the power of 5 and 2 square only. 3 is not repeated, it is only one time it is there, 101 also one time it is there. Okay, now so that according to the by definition, you can consider these two. 2 to the power of 5 and 2 square, which is the least power? 2 square, right? So that 2 square is the LCM. 2 square means how much children? 2 into 2, that is equal to how much? 4. So HCF of these two numbers is 4, right? Next LCM. Actually LCM means the product of the highest power. The product of the highest power of the given numbers. The product of the highest power of the given numbers, then it is called as a LCM. So what are the highest powers you can identify? 2 to the power of 5 and 2 square. What is the highest number? 5, no? Hence we can say that in these two, we can take in as 2 to the power of 5 is the one of the factors into. If we take 3, 3 only one time, still more nothing is there, no? So that we can take off 3, that is only the become a taken as the highest, and 101 is also only one time, so that we can take that 101 also. Now we can see children how much will be this product. 2 to the power of 5 means 2 how many times? 5 times. Just you can multiply. 2 2 are 4, 4 2 are 8, 8 2 are 16, 16 2 are 32. 32 into 3. See children, 32 into 3 into how much? 101. Otherwise 2 to the power of 4 is 32, no? 3 into 103 you can multiply. Easy, no? 3 1s are 3, 3 zeros are 0, 3 1s are 3. 3 into 101 means 303. So this 303 multiply with 32. Okay, na? So take this in here of column 303 into 32. General multiplication to children. 2 3 are 6. Okay, 0 again 2 3 are 6. Okay, 3 3 are 9. 0 again 3 3 are 9. Take now 6 9 6 9. That means how much you are getting? 9696. Just like a fancy number. Okay, so that LCM is equal to 9696. Okay, that means HCF is 4, LCM is 9696. 9696. Now we can say that what you have to see? Verification. if verification is perfect, then whatever you got HCF and LCM definitely correct. Verification you can see. What is the verification formula? Say children. LCM into HCF is equal to product of two numbers. Suppose if you think that the first number will be A, just you can imagine, and second number will be B, then in short form product of two numbers, no, simply you can write that A into B. LCM into HCF is equal to A into B. Now you can see LCM. What is the LCM value, children? 9696. 9696 into HCF. What is the HCF value? 4 is equal to product of two numbers. What is the first number? 96. What is the second number? 404. 96 into 404. Just we can check it by multiplication, children. Okay. First we can see in single digit, no, directly we can multiply. 4 6 are 24, right? 4 9 are 36. 36 plus 2, 38. 4 6 are 24. 24 plus 3, 27. 4 9 are 36. 36 plus 2, 38. 38784. This left side you are getting, LHS side. RHS also you has to get it like this one. We'll check out. 404 into 96. 404 into 96. Do the general multiplication. 6 4 are 24. 0 is 0, so that you can take 24. Again 6 4 are 24. Next one, 9 4 are 36. 9 4 are 36. You know general multiplication now. 4, 6 plus 2, 8. 4 plus 3, 7. 2 plus 6, 8. 3. 38784. 38784. Both are same? Yes. 38784. That means 38,784. LHS is equal to RHS. Hence verified. Okay. Be carefully, children. This is the one of the main important concept in these real numbers. Still more I will see that. See, one of the problem is given in the question textbook itself. What is given, you know? Check whether 6 to the power of n can end with the digit 0 for any natural number n. 6 to the power of n can be end with 0 for any natural number n. Whether it will be n with 0 or not, we can see that. What is given the number? The given number is 6 to the power of n. Okay, children. See for this solution. 6 to the power of n can be end with the digit n 0 for any natural number n they given. Okay, na? First you can see that 6 to the power of n. What are the 6 factors? That is also prime factors we have to take out. What are the 6 factors, children? 2 into 3. 2 into 3 whole to the power of n. That means you know that 2 into 3 whole to the power of n means according to exponents and powers formula, you know, ab whole to the power of m, a to the power of m into b to the power of n. That concept you can apply. 2 to the power of n into 3 to the power of n. So that means if you want to end with the 0 of the given number, okay, then when it will be end with the 0, you know. So if 5 is the one of the factor of the given number, okay, definitely it will be end with 0. But there is no 5 in this. Only 2 and 3 is there. Right? So that whenever you take n equal to 1, n equal to, n equal to 3, never be end with 0. Just you can identify. Just you can take some values. Suppose 1, 2, 3. In this we can say easily. Suppose if we take n is equal to 1, substitute in this. 6 to the power of 1. 6 to the power of n, where n is equal to 1, children. 6 to the power of 1 means how much? 6. If we take n equal to n plus 2, we can take out. That means 6 square. 6 square equal how much? 36. Again, if you take n equal to 3, that means 6 to cube. 6 cube is 6 into 6 into 6. 6 6 is 36. 36 is 216. Anyway, what is the unit places? What are the unit spaces? Only 6, no? It is not ending, no? With 0. So when it is possible, if 5 is the one of the factor in this number, then only it will be end with 0. So that 5, there is no 5 is the factor in this number. So 5 is not a factor of the given number, no? 5 is not a 5 is not a factor of the given number. 5 is not a factor of the given number. Hence what will say? It never be end with the digit 0. Hence it never be end with the digit 0. Can be end with the digit 0. Okay, children. So that it is possible only for 5 multiple, but there is no multiple, because suppose if you want to check, okay, suppose in the place of 3, if the 3 is not there, just you can think, okay, in the place of 3, if you take 5, how much will be? 2 5s are 10. Otherwise, one more factor of in this 2 into 3, still more, if you take 5, just multiply. 5 2 is 10, 10 3 is 30. Then what is the unit space? 0, no? So it is possible only when 5 is the factor of that, but 5 is not there in this factor. Both are prime numbers and also no multiple of 5 also. Hence we can say that it never be end with 0 for any natural number. So hence it never be end with the digit 0 for any natural number. For any natural number. For any natural number. That means if it is there, 5 is a natural number, you know, if it is there, this is one of factor, then only it is possible. Okay, children. Now, the next model, children. Every concept and every problem is very important. Be careful, you should practice. That model you can do as a homework, some of the problems. Okay, do these problems. 12 to the power of n. Okay, one problem. And second problem, simply you can take up 24 to the power of n. 12 to the power of n and 24 to the power of n. Is it n with the 0 or not? Just to check yourself. Okay, children? See, one more model, very important model. See what is given, you know. LCM of, that means HCF of any two numbers they given, children. Then is asking that LCM. That means what they given, you know, in what way they given, you know, given that HCF of, see what is given, 306 and 657. 306 and 657 is how much given, you know, 9. Then he is asking that find the LCM of means it simply can take a bracket also. 306 and 657. See, children, how to do this solution. So actually this is the question, no? then solution you can see that. What they given? Given that HCF of 306 and 657 is how much given? 9. So what are the given two numbers? 306 and 657. Now just you take that. Let A is equal to one of the number 306. Okay, and B is equal to 657. And HCF of these two numbers is how much given? 9. No. So that HCF is also given. HCF is equal to 9. These three details given, children. Okay, these three are given. So according to algebra, you know that in the algebraic equations, if there are four terms are there, regarding these four terms, if you know the three terms, easily you can find out fourth term. No? In the same manner, if there are the three terms, if they are given two terms, easily you can find out third term. No? Simply the given equation belongs to x, y, z, children, equal to something given. So if you know x, y, then easily you can find out z. If you know y, z, easily you can find out x. Like that. See, whenever you know the formula, with respect to this, what is the formula? We can write that we know that WKT, we know that what is the formula? LCM into HCF, LCM into HCF equal to product of two numbers. How many terms are there in this? 1, 2, 3, 4. Regarding these four, they given three terms. Then easily can find out fourth term, no? So what is missed the term? You can see LCM into HCF. What is the LCM? What is the LCM of these two numbers? Not given now. So that you can keep it up. LCM into HCF. HCF how much given? 9 is equal to A into B. What is A? 306. What is B? 657. What you call these two numbers? The given numbers. We didn't take, they given. Okay. So that now you want, according to algebra, you know that LCM is equal to, LCM is equal to what will become? First you have to write that number, no? These numbers 306 into 657 by how much? 9. So 9 is divisible by 306 or 657, just you can see. So you know that divisibility test for 3 as well as 9, just you can check it by adding these numbers. 3 plus 6, 9. Definitely it will be divisible. Here 6 plus 5, 11. 11 plus 7, 18. Then also divisible. So that 9 we can choose, 9 we can take and choose in these two numbers any one of the number to cancel. Okay now. Suppose if you want to cancel 9 in 306, just take it. 3 9s are 27. Okay, 36 will be 4 9s are 36. Right? So what is left now? 34 into 657. 34 into 657. Then multiply 657 into 34 in your prof column. 657 into 34. See multiplication, 4 7s are 28, 4 5s are 20 means 22, 4 6s are 24 means 26, right? 3 7s are 21, 3 5s are 15 means 17, 3 6s are 18 means 19, right? Then what will become now? 8, 3, 13 no, 3, 6 plus 7, 13, 10 plus 2, 12, here 2. Double 2, double 3, 8. Just like a prime number. Double 2, double 3, 8. So 22,338. 22,338 is the LCM of which numbers? 306 and 657. So in this case, children, they may give the two numbers A and B and LCM given means what we have to find out? HCF. In the same way, they may give regarding these two numbers, any one of the number they may give. That means suppose A given, not given. Okay, one of the number is 306 and HCF and LCM they will give. One of the number is given, LCM given, HCF given. Out of 4 terms, how much given? How many are given? 3 given. Out of 4, if you know the 3 values, easily you can find out the fourth term. No? So we can find out what is the another term. By using what formula it is? this formula only. According to algebra, we can say that LCM into HCF equal to A into B. From this formula, you can get it the auxiliary formulas remaining. How to find out whatever you want according to given questions, you can see. If you need LCM means directly A into B by HCF. You know that. If you want HCF means A into B by LCM. If you want only A value means LCM into HCF by B. If you want B value means LCM into HCF by A. So according to the auxiliary formulas, whatever missed the number by using this formula, definitely we can get it. So regarding in these real numbers, one of the most important this problem. Okay. So be carefully practice. Next, see children, some of the important problem. Explain why these numbers is a composite number or composite numbers. They given suppose 7 into 11 into 13 plus 13 is the one of the number. Okay, 7 into 11 into 13 plus 13 is a composite number. Is composite number they given. Why it is composite number? You have to find out. Just you can identify why it is composite number, children. See here 7 into 11 into 13 plus 13. So whether it is composite number we can identify. Okay, now first you can identify whatever given the sequence. Before going to simplifying the sequence, what is the prime number must see. What is the prime number? Prime number means what? How many factors it is having? How many factors? More than 2 factors. Okay, that means the numbers which are having more than 2 factors, they are called as a prime number. Exactly 2 factors means what you call? More than 2 factor means composite number. Okay, that means the two numbers which are having more than 2 factors, they are called as a composite number. Exactly 2 factors means what you call? Prime number. Because of prime number is having only one and itself. If you take that 17 factor, what is there? Only one only, no? So 1 is the one of the factor and 17 is the another factor. That means 1 and itself means if we consider 17 means 1 is one of the factor, 17 is the another factor. How many factors you are getting? 2 factors. So when you are getting exactly 2 factors, what you call? They are the prime numbers. More than 2 factors, then only you can say that it is a composite number. Just we'll check this now. 7 into 11 into 13 plus 13 is there, no? Simply you can write 13 into 1 children. No problem. What will happen? When you are taking common factor, easily you can identify. Okay, most of the children directly we can take up. Some of the children they will be confused. If I write after taking the common factor, 1 is the remaining. So that you can write 13 into 1, 13 ones are 13. So what is the common factor now? 13, right? Take that 13 is the common factor. 13 of what is left you can write. 7 is left, 11 is left, plus here 1 is left. That means 13 into 7 11s are 77. 77 plus 1, 78. Actually enough these two factors, 13 into 78, and one more factor is there, one is the factor, no? 3 factors you are getting. Still if you want you can check these 78 factors. Okay, now in the prime factorization you can identify. Okay, now suppose if you take the two table easily, 3 2s are 6, okay, 3 2s are 6, 9 2s are 18. Again which table will go? 3 table. 13 3s are 39. Again 3 table, 13 times. Okay, that means according to in this case, what are the factors you can write? Yeah, 13 is the one of the factor and the 78 factors these are there. 2 into 3 into 13. That means 13 how many times will be there? 2 times. 1, 2, 3, 4. Otherwise we can write in exponent form also. 13 into 13, 13 square into 2 into 3. So it is crossing more than 2 factors now. Here 2 factors are there, here 3, 4. 2 factors are equal factors, then also consider as a factor now. Anyway, it is having more than 2 factors. Can we say that it is a composite number? Hence, okay, we can say that. Hence, 7 into 11 into 13 plus 13 is a composite number. Is a composite number. Is a composite number. They ask why no? Because it has more than 2 factors. Because it has more than 2 factors. Okay, children. So this is the one of the concept in this real numbers, very important concept only.